How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for 20.9 electrolysis. So we want to describe the process of electrolysis, how it's set up and its importance in modern materials, and quantitatively determine the amount of work done during this process. So long story short, you need a power supply for electrolysis and, for example, a battery. So you hook up a battery to your electrolytic cell. You have the anode hooked up to an electrode that is going to be the cathode of the electrolytic cell. So the electrons flow from the power supply out of its anode into the cathode of the electrolytic cell. And what's going to happen there? Reduction. So for example, if I'm electrolysing sodium chloride, right? Lyse means to break apart. Electro means electricity. So we're using electricity to break apart sodium chloride. Well, when you melt it, we have sodium plus ions that can be reduced to become the sodium metal. And at the anode of the electrolytic cell, we have Cl minus, which can be oxidized to become Cl2 gas. So we're breaking apart the compound sodium chloride, for an example, using electricity. All right, so one of the differences between a voltaic cell and an electrolytic cell is that a voltaic cell produces volts. It's spontaneous. And electrolytic cells need volts. You need to apply voltage because it's non-spontaneous. So those are the big differences between the two. And going back here, this portion up here is the voltaic cell. And then this portion down here is the electrolytic cell. Right? This is where the electrolysis is occurring. Number two, what is a Coulomb? It is an amount of charge. Right? That's where the Faraday constant comes from. We go, hey, what's 1 mole of electrons? How much charge is on that? That's 96500 coulombs of charge. And we also know, relatedly, amperage, which is a measure of power, is 1 coulomb per second. So if you're like, how much power is flowing through there? Well, 1 amp is 1 coulomb of charge every second, passing a given point. All right, number 3, how many minutes will it take to plate out 2.19 grams of chromium metal from a solution of Cr plus 3 with a current of 39.5 amps in an electrolytic cell? So again, I know 39.5 amps, I can rewrite as 39.5 coulombs per second. So now let me go to my question, because I got to figure out what they're asking me. They're asking me how many minutes. Now there's a problem with what I got written right here. It has charge over time, and I'm trying to solve for time. So what I'm going to want to do is I'm going to want to flip that whole thing, take the inverse. So instead of having 39.5 coulombs per second, I'm just going to write, hey, 1 second over 39.5 coulombs. It's the same ratio. So, but now I have my time on top. So now I can start to try to correct and convert, do some dimensional analysis. All right, well, what do I know about coulombs? I know that there are 96,500 coulombs per 1 mole of electrons. That's going to take care of my coulombs. All right, so now I got moles of electrons. I need to figure out how many moles of electrons does chromium need to be reduced? Well, I know it's going from Cr plus 3, and if it's being reduced to its metal, I need 3 moles of electrons for every 1 mole of chromium. Okay, so far so good. Well, they gave me grams and they didn't give me moles of chromium. So I gotta figure, let me look up the molar mass. So I know that 1 mole of chromium is 52.00 grams, right? That way the moles of chromium cancel out, my moles of electrons cancel out, my coulombs have already canceled out. So now I got, let's see, seconds per gram. So I got to times it by, well, how many grams are they talking about? 2.19 grams, 2.19 grams. My grams will cancel out. So now I just got seconds, but they want minutes. So I got to go, all right, well, if seconds I have on top, my conversion factor is going to have seconds on the bottom. And I can put minutes on top, and I know that 1 minute is 60 seconds. So now I have my setup where the only unit I'm left with is minutes. So I pick up my calculator and I beep bop, boop. and I get 5.14 minutes as my final answer. All right, let's try another one. 4. How many grams of aluminum are produced in 60 minutes by electrolysis of AlCl3 at a current of 12 amps? So again, it might be useful to go, hey, 12 amps, 12.0 amps is really 12.0 coulombs per second, and they want grams. All right, well, let's see. I got coulombs per second. This is an amount over time, and they give me time, so I think I'm going to leave it how I wrote it, with coulombs on top and seconds on the bottom. So I got 12.0 coulombs every second, 60 minutes. Let's start there. I know that if I want to cancel out seconds, I got to put it on top and minutes on the bottom, and I know that 1 minute is 60 seconds. So now I got my minutes. But it wants it for 60 minutes, so I got to times it by, hey, for 60 minutes is the whole thing, so 60 minutes over 1. I have my total coulombs, so that's a good start. My minutes cancels out, my seconds cancel out. I got coulombs, but I got to convert coulombs to, like, you know, electrons, because I'm talking about going from Al plus 3 to Al 0. So I'm talking about electrons here. Well, I know that means we're gonna have to put coulombs on the bottom, and I know that 1 mole of electrons is that 96500 coulombs. Coulombs cancels out. So now I got to take a look, well, how many moles of electrons will I need? Well, it looks from plus 3 to 0, tells me that there are going to be 3 moles of electrons for every 1 mole of aluminum. All right, now what? Well, they want grams. All right, so now I got to go, hey, I know that 1 mole of aluminum is, let me look up the formula mass for aluminum, 26.98 grams for 1 mole of aluminum. And let's see, I think everything cancels out except for grams, which means I have set it up and I can beep bop, boop, get 4.03 grams as my final answer. Grams of aluminum. All right, so just, you know, dimensional analysis. All right, number 5. The number of kilowatt hours of electricity required to produce 4.60 kilograms of metallic sodium from electrolysis of molten sodium chloride is blank when the applied EMF is 4.50. All right, so we know that the work being done is equal to the number of moles of electrons times the Faraday constant times the voltage that's being applied. So let's do a little math. All right, so I got 4.60 kilograms. Let me convert that to grams. So I end up with 4,600 grams. And if I'm talking about moles of electrons, I have to figure out how many moles of electrons that many grams of sodium metal needs to be reduced. So I go, all right, well, I know that it's 1 mole of electrons is to 1 mole of sodium metal, because I'm going from Na plus to Na0. So I know that I gotta figure out how many grams. Well, this is how many grams. How many moles is that? So I gotta divide 4,600 grams of sodium divided by the gram formula mass of sodium, which is 23.0 grams per mole. And that's going to tell me how many moles of sodium and how many moles of electrons, because it's 1 electron per mole. But when I plug and chug and I get that, I get roughly 200 moles. All right, so that's 200. That's my N. My F is a constant, my E, they told me. So let's plug and chug. I got 200 moles of electrons times F 96500, which is really like coulombs per mole of electrons, which means moles of electrons cancels out, times the voltage of 4.50 volts. And when I pick up my calculator and I beep bop, boop, I get 86850000 joules. But they're talking about kilowatt hours. So what the heck is a kilowatt hour? Well, I know I'm going to erase this so I got more room. Kilo means 1,000. Watts is a measure of energy. So 1 watt is 1 joule per second. So kilowatt is 1,000 joules per second. And a kilowatt hour is this times by an hour. So we got 60 seconds per minute and 60 minutes per hour. So when I do that math, I end up with 3.6 times 10 to the 6 joules per kilowatt hour. All right, that's how many joules is in a 1 kilowatt hour. So if I have joules here, and I know my number of joules per kilowatt hour here, how do I get kilowatt hours? Well, I divide this by that 3.6 times 10 to the 6 joules per kilowatt hour. And I end up with 24.1 kilowatt hours. All right, some interesting units that you may have not seen before. Number 6, how many seconds are required to produce 4.00 grams of aluminum metal from the electrolysis of molten AlCl3 with an electrical current of 12.0 amps? So again, I'm talking about making Al0 from Al plus 3. So I know that process is going to take 3 electrons. I got 12.0 amps and they want time. So I'm going to go, hey, for every 1 second, I have 12.0 coulombs of charge flowing because I'm trying to get time. So I want to start with my time on top. So I go, all right, well, I know that there's 96,500 coulombs of charge for every 1 mole of electrons. Coulombs cancels out. I got moles of electrons. I know that I need 3 moles of electrons for 1 mole of Al0. Now, boom, my moles of electrons cancels out. Well, for 4 grams, how many moles is that? Well, let's figure it out. I know 1 mole of aluminum is, let me look up the GFM, it's 26.98 grams. My moles of aluminum cancel out, and now I got seconds per gram. Well, now I got to times it by 4.00 grams from the problem. Grams cancels out, I'm left with seconds, so I pick up my calculator and I beep bop, boop, and I end up with 3,580 seconds. That's how many seconds it would take under those conditions to make 4 grams of aluminum metal. All right, number 7, last but not least. What current in amps is required to plate out 1.22 grams of nickel from a solution of nickel plus 2 in 2.5 hours? So we want amps. They're trying to get coulombs per second. All right. Well, we got hours, so we're going to have to convert that to seconds. And they give me grams of nickel, so I'm going to have to convert that to coulombs of charge. So let's start with the 1.22 grams of nickel. Well, what is my conversion factor going to be for the first step? Well, I know that 1 mole of nickel is, let me look up its GFM. That's a 5. What is wrong with me? 58.69 grams. So now my grams cancels out. I have moles of nickel. Well, I know if I got nickel plus 2, in order to become nickel metal, I need 2 electrons. So for every 1 mole of nickel, I need 2 moles of electrons. My moles of nickel cancel out. So now that I got moles of electrons, I can convert that into like coulombs. How much charge is that? Well, I know that 1 mole of electrons is at 96500 coulombs of charge. My moles of electrons cancel out. I have coulombs now. Interesting. I need coulombs per second. So let's figure out my seconds. I got to put time on the bottom. So I got 1 over 2.5 hours. Now let me fix my hours. I know that 1 hour is 60 minutes. My hours will cancel out. And I know that 1 minute is 60 seconds. My minutes cancels out. Now the only units I'm left with are coulombs over seconds. I have my dimensional analysis set up correctly. Let me pick up my calculator and beep pop, boop. I get 0.45 coulombs per second, which is also aka amp. So 0.45 amps as my final answer. I hope you found that helpful. I'll see you in class. Okay, bye.